Quick revision video on percentage yield calculations. So we'll start with some essentials. In chemical reactions, the yield is never 100%. In other words, the reactants aren't completely converted into the desired product. Some reasons for this could be side reactions might occur. Reaction mightn't go to completion. The reaction might be reversible. Or the process, if it occurs in stages, you might lose product on extraction between stages. The formula that we use to calculate percentage yield looks like this. So percentage yield is equal to the actual amount divided by the maximum or theoretical amount times 100, and the amount can be in moles or mass. Okay, so what I thought I'd do for the video is just put 3 different percentage yield calculations on the screen. So if you wanted to have a go at those, just pause the video and then play them when you're ready for the answers. Okay, so starting with the blue ones, this is the sort of most straightforward one. First thing I'm going to do is work out the moles of hexane 1-ol that's been reacted, mass over mR, so 0.1 moles of hexane 1-ol. The mole ratio between hexane 1-ol and hex-1-ene is telling us that we should get the same number of moles of hex-1-ene formed. So that's your theoretical or maximum moles. We're now going to work out the actual moles of hex-1-ene that's formed. So we've got 5.04 grams of it formed. So mass over mR again. 0.06 moles of hex-1-ene's formed. So we'll bring that formula into play now. The percentage yield is the actual over the theoretical times 100, so it's a 60% yield. Moving on to the next one, so the first thing I'm going to do is work out the moles of calcium carbonate used, mass over mR. So I've just kept the full number in the calculator there, so that's hence the dots. So now we're going to bring the yield into play. So we know that there's a 90% conversion, so we're actually going to make 90% of these moles. And then all we're going to do is turn those moles of calcium oxide into mass multiplied by the mR. 6.25 grams. Okay, so moving on to the final question. This is the trickiest one, I suppose. So we've got the yield and we need to work backwards to work out the mass, the starting mass of sodium hydroxide that's going to be needed to make 10 grams of sodium sulfate. So the first thing we're going to do is work out the moles of sodium sulfate that we're trying to make, mass over mR. I'm now going to apply the mole ratio and assume it's 100% yield. So to make 1 mole of this, we need 2 moles of sodium hydroxide. So to make that many moles of sodium sulfate, at 100% yield, we need twice as many moles of sodium hydroxide. I'm now going to factor in the 56% yield, so I need to scale it up to account for the fact that it's only a 56% yield. So the way I do that is divide by the yield and multiply by 100. So the moles of sodium hydroxide we're going to need 0.2513 ... And now all I need to do is multiply by the mR of sodium hydroxide to get the mass I'm going to need. And I'm putting that to 3 significant figures, which is coming out at 10.1 grams.